Am I audible?
Yes,
Am I
ma'am.
audible, dear students? Okay. So I hope we have discussed about how to handle, maximization problem or the minimization problem and different types of constraints. Any doubt to any student regarding that? Hmm? Today we have planned to discuss about the what that how to handle the special cases. The special cases pertaining that we have discussed, the unique solution we have already discussed. There's only one student in the class for the discussion. Only two. Where are others? Anshruta, in the graphical problem, in a graphical method, we have discussed the different special cases, how to handle and how we can identify. Could you name the different special cases that might occur in the linear programming problem?
Mom, just give me 1 second to recall.
Hurry up. Only 3 students are here in front of me. Where are others?
Ma'am, can you not see me?
Yes, I can see you, Paritosh. Hmm? Yes, Mohak, what are the different cases that we have discussed in case of graphical method? Now we're going to discuss in the simplex method as well. Yes, Tumpi, where are you? Aditya, Stuti.
Yes. What was the question?
Ma'am, graphical.
Good afternoon, ma'am.
Good afternoon.
I'm visible.
Ma'am, can I see?
Pardon, Anshruta?
Ma'am, can I? आप graphical cases के special cases पूछ रहे हो ना graphical method का? हाँ, so
Yes.
yeah, so that was optimal solution. Then there was a multiple optimal solution. We had the unbounded solution and the infeasible, no solution, infeasible.
Infeasible solution, no solution. So optimal solution is not the case. Unique solution is the case. Optimality, so we need to find.
Yeah.
We get one solution, more than one solution, we get unbounded solution or an infeasible solution, right? These are the different cases that might occur while solving the linear programming problem. So when we are dealing with the two decision variables, we generally prefer to have it a graphical method, and how these problems can be identified when we are solving the problem using a graphical method, we have already discussed, right? So now if you are dealing with more than two variables, we need to use a simplex method. And while solving a problem, trying to attempt to the optimal solution for the linear programming problem, there might be the instances when we need to follow, when we cover that the solution is multiple optimal or unbounded or infeasible. How we can identify that this solution is the unbounded or infeasible or multiple optimal. So we'll discuss one by one about those cases, right? So let me share my presentation. Wait. Here is, yes, introduction to LVP discussion. Wait, it's not. Is my screen visible? Is my screen visible?
No, ma'am.
No, ma'am.
Not. 1 minute. Let me again. There's an issue with the laptop. Now?
No, ma'am.
Wait, my dear students. What to do? Let me do it again. There's some issue with the internet. Can you see, my dear students?
Yes, ma'am.
Yes, ma'am.
Yes. Have I start recording the session? Yes. So today we'll discuss how to identify the different types of solution to the linear programming problem while attempting to find the optimal solution using the simplex method. And then we'll see how we can solve the problem of degeneracy or get an alternate solution using a simplex method. Okay. So what do you mean by degeneracy, right? First we learn this. So in the simplex table, when we are trying to attempt to have the optimal solution, we need to find the least ratio to identify the key row. Only 6 students are here. Where are others? Where are others?
Ma'am, Stuti is saying that she has some electricity problems, so she can't turn on her camera.
Ma'am, I have joined from the web and I have slow net today, so I can't turn on my camera.
So what about Parth, Yavar, Lakshmi Priya, Ridesh, Vaibhav? Huh? Where are others? Where are others, my dear? Ariba, Divyang, Gitanshu. They are not in the meeting?
I'm here, ma'am. Even my camera is on.
No, your camera is not
My
on, my
Ma'am, wait, I'll just spotlight myself, ma'am.
dear. Hey, beta, I thought I have put it in a large gallery only.
Ma'am, wait, I'll just.
Now you have turned on your camera, my dear. Earlier,
ma'am,
your camera is not on. Dhruv, there is no need to spotlight unless until I'll tell you.
ma'am,
Okay.
I didn't spotlight myself. Somebody did.
Please don't waste time in this type of things, my dear students. Okay. So degeneracy occurs when there is a tie in the key row. Okay. How will find the key row? Who will tell me? How will find the key row? How will find the key row?
Ma'am, by ratio.
Okay, which ratio we need to select generally?
Ma'am, least possible, the
Least
minimum.
positive ratio. When
Yes,
there is a tie, suppose there are one value 10, then it is minus 38, then it is infinity, so we select 10. So if the ratio is 10, 25, 30, we select the 10 as a key, the ratio, and corresponding to that, the row is known as a key row. So if there is a tie for the key ratio, two values are the minimum value, right? So we need to select one, right? So that problem is known as the solution is degenerate, right? And a solution to this problem is known as a degenerate solution if the value of at least one basic variable becomes 0. And in the index row, see, can you see my this? So there is a tie in a ratio, and corresponding to this we have a 0 value against S1 and S2. We have a 0 value, right, for the basic variables in the index row. Now how to resolve this kind of problem, right? So we need to arbitrarily select any one variable as a any one ratio as a key ratio. Okay, and we need to see, we have selected the first one here, S1 as the departing variable and X2 as the entering variable. And due to this, what happened, for a basic variable we have a 0 value here, right? And S2 becomes 0 in the next time. What we'll take now, we'll take the minimum positive ratio, and then we remove this 0, and then In that place, x1 enters into the system and we got the optimal solution. So whenever you find there is a tie in the key ratio, you can select anyone. If your selection is wrong, so it might take 2-3 iterations, but you can find out the optimal solution. Okay. The next case is the multiple optimal solution. How the solution, we'll said that the this problem has a multiple optimal solution when in the index row value of more than the basic variables. Non-basic variable have a 0 value in the optimal table of in the index row, then the problem have a multiple optimal solution. For a non-basic variable whose value is 0 in the index row, if that variable is taken as a basic variable to enter the system, then we get the another solution for the problem. For instance, can you see this? Right? So problem is of maximization problem, and for this problem we got the optimal solution here because all Cj minus Zj is less than equal to 0. Now these are the two variables, S1 and S2, right? Sorry, here. So we got S2 and X2 as our basic variables, and we got the optimal solution because all Cj minus Zj, here I have written Zj minus Cj, so all Zj minus Cj need to be positive for the maximization case. But apart from the basic variable X2, here the coefficient is 0. S2, here the coefficient is 0 in the index row. But apart from these basic variables, there are other variables whose value is 0 in the index row is the x1, right? So now if I take this variable as an entering variable in my next row and next table, if I'll generate, I got the same solution. That is Z value remains the same. That is known as the multiple optimal solution, right? You can see here. Next is unbounded solution. The LPP problem has an unbounded solution while solving with the linear programming method when we are unable to determine the departing variable. When we are unable to determine the departing variable, when we are unable to decide about the ratio, which ratio to be considered. So all values in the key column are either negative or 0 or infinity. Then we can say that we are unable to decide any ratio, and hence the solution is unbounded, right? So here you can see all the ratios are negative, so there is no possibility of selecting any key row, and hence the solution to this problem is unbounded. Last is the infeasible solution. The problem, LPP problem, when solved with the help of the simplex method, is said to have the infeasible solution if in the final table the artificial variable is still present as a basic variable, then the problem has the infeasible solution. Now this problem can be resolved using the dual simplex method that we will discuss in the next session. So I have given you a brief idea about what are the different cases and how we can handle. So we do it by solving the problems. I'll give you the problem. Yes, Mohak.
मैम एक बार अनबाउंडेड का बता दो फिर से कैसे देखेंगे.
Unbounded problem when we are unable to decide about the minimum ratio.
Okay.
The criteria for selecting the ratio need to be the minimum of all the ratios, but it need to be positive. This is the criteria for the ratio.
Yes,
So
ma'am.
if all the ratios are negative or infinity, and we are unable to decide about the departing variable, that means we are unable, the ratio will give us an idea of the departing variable.
बट
When
मैम
we are,
अगर पॉजिटिव और सेम हो तो हो सकता है ना.
so then this is not the unbounded. Then we need to select the least one, and if there is a tie for the key ratio, that is a problem of degeneracy.
Okay, ma'am.
ठीक है ना? And we select the any one as the key. What I say? Key row. Okay. So we have discussed the different cases in the graphical method as well, and the problem having the unbounded solution, infeasible solution. We can use we can take those problems only, and we can check that if we solve those problems with the help of the simplex method, we got the same type of issues. Okay, so let's discuss one by one. So let me stop this, and then we'll have the special cases.
Ma'am, are you sharing any screen?
Yes, give me a minute, my dear. Give me a minute.
Okay, ma'am.
I'm posting the question for you all. And to let me post in the chat box. Yes, I have posted. Amartya, can you tell me? Amartya, could you please read from the chat box the first case? Maximization problem. It's not visible on the chat box.
Ma'am, it is.
It is.
Okay.
Okay. Divyan, could you please read what is the problem so that we'll together solve it? Maximize Z.
Yes. Maximize Z is equal to 8x plus 16y. And ma'am,
Maximize Z
then
is equal to 8x plus
16y.
Okay. Next.
Ma'am, then the constraints are x plus y is less than equal to 200.
So if it is less than, then how we need to frame the constraint? For less than type constraint, we need to add surplus variable or slack variables.
Ma'am, slack variable.
So whether it is to be added or subtracted.
Added.
So I'll add S1 is equal to 200. Okay?
Yes, ma'am.
Next.
Y is less than equal to 125. So y plus S2 is equal to 125.
Anything else?
Ma'am, then the last one is 3x plus 6y is less than equal to 900. So we'll put plus
6y,
S3.
3x
Plus S3
plus S3
is equal to 900.
is also less than bacha.
Yes, ma'am. All three are less than equal to.
It is equal to which value?
900.
ठीक है.
And then the last one is, ma'am.
Non-negativity.
No, ma'am. No, it's just a condition that x and y are greater than equal to 0. Yes.
Constraint. So
Yes.
let me readjust my this objective function as well. ठीक है? The coefficient of slack variables in the objective function are 0. ठीक है बेटा?
मैम क्या बोला आपने लास्ट चीज मैम?
So we have added the slack variable in the constraints, and now we have adjusted our objective function based on that. ठीक है ना? ठीक है?
Yes, ma'am.
So this is a first step. Convert inequalities into equalities and find the initial basic feasible solution. Find for finding the initial basic feasible solution, we need to put what? Aditya?
Yes, ma'am.
Decision variables
Yes, ma'am.
equal to 0.
Yes,
When
ma'am.
we put decision variable equal to 0, what we get?
S1 200, S2 125, S3 900.
S1 200, S2
125 and S3 900.
and Z.
And Z would be 0, ma'am.
Can we put the values in the initial table?
Yes, ma'am.
All right, hurry up. We have 3 constraints, so 3 rows we need to make. ठीक है ना बेटा? Please put the values in the first table. What we put in the CJ? Coefficient of the decision variables and the slack variable and all the other variables based on the objective function. Yes, Khushi Mittal, you tell me what should I write here in the CJ? Khushi?
Yes, ma'am. Ma'am, 8, 16, 0,
16.
0, 0.
Because we have 3 slack variables. ठीक है?
Yes, ma'am.
Okay. Tumpi, tell me the name of the basic variables. Which we got from the initial basic feasible solution.
S1, S2, S3.
So what are their values and what we write in the CB?
CB would be 0. CB would be
0, 0, 0.
yes.
XB is S1, S2, S3. And what should I write in value?
200,
Hmm?
125 and 900.
Okay. And in ZJ, what should I write?
ZJ would be, we have to plus all the 3.
Right.
Wait a minute.
ठीक है. So
हम ZJ भी सारे 0 0 0 ही आएंगे तो.
हाँ जी बेटा. चलिए, how we'll write the first row? Hurry up. In the first row, what is the value? What is the coefficient of X, Y, and others? Aditya, please tell me.
Right. Ma'am, 2.
Why 2?
Ma'am, it's 1 1 1 0 0
5 plus
1
S1.
0 0.
0 0.
What about the second row?
0 0 1 0 1 0.
And third row?
1 3 0 0.
1.
Ma'am, 3 6.
P6
मैम 3 6 है
3 6 0 0 2. 1 sorry 1 1.
ठीक है. Okay. Yes, Smriti Mata.
Yes, ma'am.
Calculate ZJ minus CJ and decide about the key. Check the optimality criteria.
Okay, ma'am. Doing.
Tell me so that I'll do with you.
Yes, ma'am. Wait a minute. Ma'am, ZJ will be 0 0 0. Huh. Yes, ma'am. CJ minus ZJ will be 8 16 0 0 0.
Right. So make sure that against basic variable you have 0 in the index row. Against basic variable there should be the identity matrix in the row side. So these are the things that you need to check whether your calculation is right or wrong. Now what is the criteria for optimality, Smriti?
Ma'am, we need to calculate the ratio.
No, for calculating ratio we need key column, and
Most
for
positive.
deciding about the key column first we need to check the optimality criteria. So it is a maximization problem. So what is the optimality criteria?
Cj minus Zj should be less than equal to 0.
Less than equal to 0, and if it is not applied, so we'll select the most positive.
So which one I need to select?
Ma'am, 16.
Ma'am,
And yes.
Ma'am.
And this column is known as the key column.
Key
ठीक है
column.
ना?
Yes, ma'am.
Now find the ratio. Find the ratio, my dear.
Ma'am.
हाँ जी बेटा.
Ma'am, least positive में 8 ही नहीं है.
I'm not getting what you are saying. Please.
Ma'am, हमने 16 लिया है. So the condition should be Cj minus Zj less than equal to 0.
Aditya, I am unable to understand. Please, a bit louder. Tell me.
Now is it okay?
Tell me.
Ma'am, the condition. Ma'am, can you remove this screen camera so I'll tell you. Yes. Ma'am, the condition for maximization is Cj minus Zj should be less than equal to 0. So,
Otherwise
the least positive.
Least positive, nahi, most positive.
Most positive.
Most positive. So we have selected the most positive value. And what is how we calculate key ratio, Smriti?
Ma'am, value by key cell.
Key column.
Yes, ma'am, key column.
चलिए calculate करिए.
Ma'am, it's 200, 125 and 150.
100, 125 and
150.
Criteria for selecting the ratio?
Ma'am.
Ma'am, least positive.
Least. हाँ मोहक.
मैम जैसे इसमें क्राइटेरिया तो लीस्ट पॉजिटिव है, बट अगर मान लो 1 का 0 आ जाए रेशियो, सॉरी माइनस में आ जाए मतलब,
तो उसको नहीं सिलेक्ट करना. माइनस रेशियो लीस्ट में नहीं. लीस्ट पॉजिटिव इज द क्राइटेरिया,
और
नॉट
जीरो
द
आ
लीस्ट इज द क्राइटेरिया. लीस्ट पॉजिटिव इज द क्राइटेरिया माय डियर.
ओके.
चलिए. We have decided about the departing variable and we have decided about the entering variable, and this element is known as a key element which comes at the intersection of key row and key column. ठीक है? Now coming to next table, hurry up. Hit the next table. So here I am going to write y, and this row we need to divide 125 divided by the key element, so it remains the same. ठीक है ना? All right. So these two, here is the value 16. Rest everything is okay. Now what we need to do? Yes, Mohan. Tell me, what is the first row? This first row element value minus this, the value corresponding to the new key, minus the key element, the element corresponding to the key element multiply by this. So what it is?
Ma'am, the first row will be 75.
75. Oh,
1.
Then it is 1. Okay.
0.
Then?
Ma'am, 0 ही तो होगा 1 minus 1.
How 1 minus 1?
अच्छा मैम, वो सॉरी मैम 1 नेक्स्ट 1 हो जाएगा, आपने 0 ऑलरेडी लिख दिया. 1 then -1
-1.
then 0.
What about the third row?
Now I'm calculating, just a minute.
It is 900 minus 6 into 125. 900 minus 900. Yes, na? The 900 minus 6 into 125. Yes.
Ma'am,
हाँ जी बेटा.
ma'am, it will be 150.
Okay.
The 3
Then 3
0
0
0
0.
-6
Here it is
and
-6.
and 1.
So now we'll calculate ZJ.
Ma'am, 2000 value.
We have 0, then we have 16, 0, 16 and 0. ठीक है ना? It's okay. Can we calculate CJ minus ZJ? Yes, Smriti, tell me मेरा बच्चा. CJ minus ZJ.
Ma'am, 8 0 0 minus 16 and 0.
What is the criteria?
Ma'am, most positive.
So in this scenario, what it is?
Ma'am, 8.
8. So now we calculate what? Ratio.
Yes, ma'am.
So 75 divided by 1, it is 75. Then 125 divided by 0, it is what? Infinity. Something divided by 0 is what? Infinity, na?
Infinity.
And then we have 150 divided by 3, which is equal to 50.
50.
Okay? And the criteria for the ratio is least positive. So infinity is the most positive, so we need to select the least positive. So departing variable is what?
S3.
S. And the key element is
3.
we make the next table. Now table 3. So in place of S3, which variable to take place?
X.
What is the value in the CD for X?
8.
8. And what are the values corresponding to this? For the third row, which becomes equivalent to the key row. How we'll calculate? With every value, we need to divide by the key element. That is with 3. 150 divided by 3 is 50. 1, 0, 0. Then what? -2. And then 1 by 3. ठीक है? Can we calculate the other values? You will tell me the elements for the first row now in the third table against S1. 75 minus 1, this element corresponding to the key element. 75 minus 1 into 50. What it is? 25. Calculate please the first row and the second row. Hurry up. हरी अप बेटा बताइए.
मैम सेकंड वाली सेम नहीं रहेगी?
क्या सेम रहेगी बच्चा?
सेकंड रो.
सेकंड रो कहाँ सेम रही? आपकी सेम रही है बच्चा? बताइए क्या वैल्यू आई? फर्स्ट रो की क्या है कंपोनेंट्स?
फर्स्ट रो की 25 0 0 1 1 1 माइनस 1/3.
1 देन व्हाट?
हम दो बारी पहले 25 फिर दो बार 0 फिर दो बारी 1
हाँ
फिर माइनस 1/3.
-1/3. ओके नेक्स्ट.
नेक्स्ट की मैम जो पहले टेबल में सेकंड रो थी वही सेम नहीं होगी इस टेबल में?
The value is second row minus 0 into, because the element corresponding to the key element is 0 na. So when something is multiplied with 0, हाँ, तो it remains same. 125 0 1 0 1 0. Yes, Mohak?
Yes ma'am.
Okay, now calculate ZJ.
Ma'am,
Ma'am
2400.
first car 2400.
2400.
Then
उसके बाद 8
8.
then 16
Then
then 0
0.
yes ma'am.
Then 8/3. Huh?
Yes ma'am.
Now CJ minus ZJ.
Ma'am, 0 0 0 minus 8/3 last.
What is the optimality criteria?
Most positive.
What is the
No.
optimality criteria?
No, ma'am, no, ma'am.
All Cj minus Zj need to be less than 0 for the
Yes.
maximization problem.
Yes,
So
yes.
here the optimal condition met, and the optimal solution is x to be 50, y to be 125, and z is 2400. But this problem has a multiple optimal solution. Why? Because apart from the basic variables, you can see these three are the basic variable: x, y, s1. So x value in the index row always 0. Y value, because y is a basic variable. In every table, the basic variable coefficients are 0 in the index row, right? So x is 0, y is 0, and s1 is 0. And these two, s2 and s3, are the non-basic variable. If any of the non-basic variable is also having a 0 value in the index row, then the problem having the multiple optimal solution in the final table where you got the solution. Okay, so if in a final table apart from the basic variable, that is the non-basic variable also have a zero coefficient in the index row, then the problem having the multiple optimal solution. You can find the alternate solution by selecting that as a key column. Okay, so we can find the alternate solution by selecting this non-basic variable corresponding to which we have a zero coefficient in the index row as a key column. So here we'll have the ratio 25 divided by 1 is 25, 125 by 1 is 125, 50 minus 2 it is minus 25. So the criteria is least positive. So we select this S1 as my departing variable and S2 as my entering variable. Now you can have the next table, and in that table we can see we got the same Z value, that is 2400 with the different values of the basic variables. We can find and we can check. So our first row is a key row and here is a key element, so it remains same. The only thing is here we have S2. And the coefficient of S2 is also 0. So this remains the same. And the rest two rows we'll calculate. All right. And chaliye, let's calculate the second row corresponding to this. 125 minus 1 into 25. So it becomes 100. So 0 minus 1 into 0, it is 0. 1 minus 1 into 0. 1 minus 1 into 0, it is 1. 0 minus 1 into 1, minus 1. And then 1 minus 1 into 1 minus 1 into 1, that is 0. Then 0 minus 1 into minus 1 by 3, it is 1 by 3. Yes, my dear students? Is it fine? Is it fine, beta? Yeah. Second row, ठीक है? Can you see my screen? Okay, Anshuruta, tell me what are the values for the third one? 50 minus 2 into 25. So it becomes 0?
0, yeah.
Please calculate. We have calculated the values correctly ना मेरा बच्चा, वो check कर लेना एक बार.
Ma'am, can you share your screen again?
All right. So it is now it is 1 by 3 minus 2 into 1 by 3. 1 by 3 minus 2 by 3. 1 minus 2 minus 1 by 3.
Minus 1 by 3.
ठीक है? All right. Now can we calculate ZJ, Anshuruta?
Yes, ma'am.
1600.
How 1600?
16 into 100.
See, here we have minus 2, na? So 25 minus 2 multiply by 50 minus 2 into 25.
मैम वो जीरो होगा ना वैल्यू में x के सामने वाला वैल्यू.
नहीं मेरा
मैम
बच्चा,
ZJ तो 0 into 25 ऐसे ही तो कर.
please listen to me. Yeah, we need to calculate value corresponding to 50 na, so it is 50 minus 2, then in bracket element corresponding to the key element is minus 2, so we have minus 2
into 25.
into 25, so what it becomes 100 na, 50 minus plus.
मैम 2 into minus 2 क्यों कर रहे हो?
मैम वही.
Wait मेरा बच्चा, inside we have minus na, and then we have minus, तो 100 ही आएगा.
50 plus 50 वो हो जाएगा 50.
50 plus 50 तो 100 हुआ ना.
हाँ.
So 1600 plus 800, 2400. 8, 16 minus 16
Yes,
plus
ma'am.
16, 0. Then we have 0. Then 16 by 3 minus 8 by 3. 16 by 3 minus 8, 8 by 3.
8 by 3.
So Cj minus Zj is what? 0, 0, 0, 0, and then we have minus 8 by 3. So optimality criteria we are able to meet. Yes, all Cj minus Zj is less than or equal to 0. But here the x and y, different combination of x and y will give us the same maximized value of our objective function. So the problem having the alternate solution. You can see for the basic variable x, y and s2, we have the 0 value. These three are the basic variable and their coefficient in the index are 0. Apart from that, there is one more variable, non-basic variable, whose coefficient in the index row is 0. So if I enter this, so I'll reach here only, right? So the criteria to find the alternate solution in the simplex method is that for non-basic variables, if we have a 0 coefficient in the index row in the final table, then the problem having the alternate solution. And if we take that as a key column, we can find the alternate solution. Is that clear?
Yes, ma'am.
Right? So I'm giving you another question. This you need to do on your own. Let me give you the question and then I'll take your attendance. And you need to tell me what type of solution this problem has. Let me post in the chat box. Tumpi, is it visible?
Yes, ma'am.
What it is, could you please read?
Maximize z equals to 20x plus 30y. Constraints are 2x plus y less than equal to 40. 4x minus y less than equal to 20. And the third one, ma'am, x is greater than and equal to 30. And
Non-negativity constraint, x, y both need to be positive. So what is the first step that we need to take further?
Inequalities into equalities we have to do. We have to plus si select variable. First one we have to do s1 and the second one also we have to do plus. Third one we have to minus. Since it is maximized question, we have to minus minus s3 and minus a1. arbitrary. We have to find.
You just tell me how the constraints. So I cannot see what is there in the chat box. You help me in framing the equalities. 2x plus y
Yes. Plus S1 equals to 40.
equals to 40. Okay, next one.
4x minus y.
Huh?
4x minus y plus S2 equals to 20. Third one, we have to do x minus S3, x minus
Minus S3
minus A1
plus A1. Artificial variable need to be added.
मैक्सिमाइज में तो माइनस था.
नहीं, माइनस नहीं. Coefficient of artificial variable in the objective function is minus m, not in the constraint.
Okay.
ठीक है? It is equal to what, my dear?
30.
30.
Non-negative.
And how I need to reframe my objective?
Z equals to we have to do first we have to do 20x plus 30y plus 0s1 plus 0s2 minus 0s3 plus me1.
It is plus or it is minus? Please check. It is based on the, depending upon we are having the maximization objective function or minimization. If we have the maximization objective function, then the coefficient of artificial variable in the objective function is minus m, not m. Tumpi? ठीक है?
Yes, ma'am.
Now, can we have the initial basic feasible solution? For that, we need to put decision variable, decision and surplus variables equals to 0. So we have xy decision variable and we have one surplus variable, that is S3. So when I put all these equals to 0, what I got? S1 equals to 40, S2 equals to 20, A1 equals to 30, right? And Z is equal to what? 0, 0, 0, 0, 0 minus MA1. No, minus M. Right? Right, my dear? Now put the values in the initial table. We have two decision variables and then we have this A1 also. ठीक है ना?
मैम S3 की वैल्यू नहीं निकलेगी?
नहीं बेटा, S3 we need to put, S3 is a surplus variable. Surplus variable we need to put 0. We need to put the surplus variable equals to 0 as the decision variable for the initial basic feasible solution. Okay.
मैम
हाँ जी.
मैम एक डाउट था
हाँ जी.
लास्ट क्वेश्चन में, एक बार शीट चेंज कर दी.
Tell me.
मैम लास्ट क्वेश्चन में टेबल 3 में भी हमारी CJ माइनस ZJ और टेबल 4 की CJ माइनस ZJ सेम आ रहा था, तो हमने टेबल 3 से ही ऑप्टिमल सोल्यूशन क्यों नहीं निकाला?
Table 3 is the optimal solution, Simriti, but I am telling you that in the optimal table, the non-basic variable have a 0 coefficient in the index row. That clearly indicates that this problem for this problem, we have the multiple optimal solution.
Okay, ma'am.
Multiple optimal solution means the other solution for the same problem also exists. That the other combination of x and y also give us the same value of z. Okay?
Okay, ma'am.
That is why from the third and the fourth table we got the same z value.
Yes, ma'am.
Okay?
Okay, ma'am. Okay.
Okay. I'm helping you for this one first table. Rest you need to do and tell me what type of solution this problem has. Okay. Let me remove everything. All right. So objective function coefficient for x is 20, for y it is 30, 0, 0, 0, and we have minus m. It is 20 minus m. Values we have 40 and we have what?
20.
20 and then we have 30.
30.
Here we have 0, 0 and minus m. Okay. And here we have, here the values are 2, 1, sorry, 1, and after that we have 0, 0, 0. Then we have 4, minus 1, 0, 1, 0, 0. Then we have, what it is?
1.
1, 0, 0, 0, minus 1 and
Minus 1 and 1.
Okay.
1.
And here we got minus m, 0, 0, 0, m and minus m. Okay.
Yes, ma'am.
So here we got 20 minus m. Then we have 30.
30.
Then we have
0.
0, 0. Then we have
M.
minus m.
Minus
0 minus m is minus m, na? See, 0 minus m is minus m. Okay. Now the problem is maximization. All Cj minus Zj need to be less than 0. Else we need to select the most positive. This is negative. This is negative. We need to select the most positive. So y is my entering variable to the system. Now we need to calculate the ratio. My humble submission is please do the needful and please let me know what kind of solution this problem have in the next session. Right?
Yes,
Okay. All right, my dear students. I
मैम
have
ये
my
वाली
another
एक्सेल
class.
शीट शेयर कर दो.
तो रोज यही शीट पे काम कर रही हूँ मैं कर देती हूँ. I
Yes,
have
ma'am.
my another class. Let me save this and जितना भी हुआ है I'll share.
Yes, ma'am.
LPP Simplex.